All right, so section 3.6, curve sketching. So I'll give you a couple of guidelines, I guess, for things that you need to find when you're doing this stuff. So um, helpful tips. All right, so number one, we're going to want to determine the domain and range. Sometimes it's good just because trying to figure that out will give you like vertical asymptotes, horizontal asymptotes, that type of thing. So number two, determine the intercepts and asymptotes. Now by intercepts, we're talking about x and y intercepts. And asymptotes. And for asymptotes, we're talking about vertical and horizontal. Number three, find f prime of x, set it equal to 0 to find where it increases and decreases. Whoops. Decreases. And then number four, find f double prime of x equal to 0 to find concavity. Five, sketch. Now, all of that, 5 steps doesn't seem like much, but when you think about the amount of steps it takes to do like step 3 and step 4, this can get incredibly long, okay, depending on the functions. So when you're going through this, don't get frustrated that you're doing a problem for 5 to 10 minutes, okay, because it does take a while. Okay, curve sketching takes a little while to get through. It's not always the easiest thing to do. Based on your ability to take derivatives, it could be easier than other times because if your derivatives aren't correct, then you're going to be solving for stuff that doesn't make sense. Okay, so I always tell people, since you guys have the ability to have a graphing calculator or at least have a program like Desmos, you could always graph the original function. That way, when you solve for your critical numbers, you can look at your original graph on Desmos, let's say, and say, okay, yeah, right there, it looks like it's going from increasing to decreasing, so that's good. So, okay, I found that one out, etc. Okay, and then when you look for concavity, you look at it and you're like, okay, yeah, that does look like it's concave up, concave down, that type of stuff. So it's always nice to have a reference. That way, as you're doing your work, that you're doing it right. So you guys have that ability that I never had. Whereas for me, I was just kind of hoping because we didn't have the graphing calculators at that time. So yeah, use your resources. Okay. So here's example number 1 for us. By the way, there is no new teaching in this lesson. Okay, this is all stuff you're supposed to know how to do already. Maybe except for the sketch part, but we're gonna kind of do that right now. But there is no like new information that you've never seen before. So we're gonna analyze the graph of f of x equal to 2x squared minus 9 over x squared minus 4. Okay, so a couple things, if you can figure some of these things out here, but the domain and range part from step one isn't always the most necessary thing to do. You don't have to figure that out if you don't want to, but you do have to figure out your x and y intercepts. Okay? So to find your x and y intercepts, let me just put right here x intercept, y intercept. So to find my, let's say y-intercept, I let my x values equal 0, right? So to do the x-intercept, I'll put it right here. And I'm sorry, not x, y. I'm going to set x equal to 0. So I get y equal to 2 times 0 squared minus 9 over 0 squared minus 4. So that's equal to 2 times 9/4, which is 9/2. So that means that my y-intercept is 0, 9/2. Okay. Now, if I want to figure out my x-intercept, all you have to worry about is setting your numerator equal to 0. Okay, so for x-intercept, set numerator equal to 0, or y equal to 0. Now, it just depends. If it's a fraction, then you want to use the numerator, set it equal to 0, which basically means setting y equal to 0. But sometimes if it's not a fraction, then you can just set y equal to 0 if it's just a normal polynomial, and then you solve. Okay, so one of those two you're going to do. So I'm going to set my numerator equal to 0. So 2 times x squared minus 9 equals 0. So that means that x squared minus 9 is 0. X squared equals 9. So that means that x is going to be plus or minus 3. So my x-intercepts are at plus or minus 3, 0. Right, so I found my y-intercepts, I found my x-intercepts. That's great. Now I got to try to figure out my asymptotes. Right, so let's find my vertical and my horizontal. Now notice all this work that we're doing is still step 2. Okay. So to find my vertical asymptotes, you always look at your denominator, right? And you ask yourself, for your denominator, what will make that equal to 0? So I'll do the work here. Vertical asymptote. I'm going to set my denominator equal to 0. So that means that x is going to have a vertical asymptote at plus or minus 2. So vertical asymptote plus or minus 2. How do we find horizontal asymptotes again? We just went over this on Friday. Yeah, look at the powers when we take a limit, right? So we're going to basically find the limit as x approaches infinity of 2 times x squared minus 9 over x squared minus 4. Okay, now some people like to distribute the top portion, so it'll look like this. Limit as x goes to infinity of 2x squared minus 18 over x squared minus 4. What's my limit for that? It's just a 2, right? Notice the powers the powers are identical. And if the powers are identical, that means that you take the coefficients, which would be 2 over 1, or just 2. So that means there is a horizontal asymptote at y equal to 2. So I'm going to put that way up here. So that was step 2. Notice we didn't do the domain and range. Again, it's not like super important that you do it. But finding step 2 is really important. And these are the answers for step 2, the x-intercept, the y-intercept, the vertical asymptote, the horizontal asymptote. I have all that stuff. But now I got to figure out critical numbers and points of inflection. So again, you see how much work is going into this, right? Just one problem. So before I do any of that, anybody need any explanations on the y-intercept, x-intercepts, or the asymptotes, vertical, horizontal? Notice we've done this before. The x and y-intercepts you've done from Algebra 1. The asymptotes was pretty much an Algebra 2 thing, but the horizontal ones, we kind of learned a little bit in trig, okay, and again during calculus. So there's a little bit of new knowledge there. So all right, so let's go to the derivative. So I'm going to do that right under the asymptote part, okay? So I'm just going to kind of put a box around this stuff here. These aren't all the answers, but I just kind of want to show that that's important for what we're going to do. Let's do our derivatives. Now, our derivative is not going to be super nice, okay? Because it's one of these fractions. So I'm going to rewrite it over here. I'm going to try to see if I can draw the graph right in that big space right there, okay? So we'll do the derivative here. So if f of x is 2 times x squared minus 9 over x squared minus 4, I'm going to multiply that 2 in, just like we did earlier, 2x squared minus 18 over x squared minus 4. And I'm going to take the derivative of that. Now, since that's a fraction, that means I need a quotient rule. Okay? So you guys can start the quotient rule. I'll do that as well. F prime of x is equal to, now the derivative of the top function. Okay, remember I'm using this piece right here. Okay? The derivative of the top function would be 4x minus 0. So just 4x. Times the bottom function, x squared minus 4, minus the top function, which is 2x squared minus 18, times the derivative of the bottom function, which is 2x minus 0. Okay, the derivative of x squared minus 4 is 2x minus 0, or just 2x. And then you got to divide all of that by the bottom squared. So x squared minus 4. And then quantity squared. So let's start working this problem out. Let's try to simplify as much as we can. So I get 4x cubed minus 16x minus, that's going to be a 4x cubed minus a, what is that, 36x divided by x squared minus 4 squared. Now notice how we have a 4x cubed minus 4x cubed right there. This is actually going to cancel out, so that's nice. And then a negative 16x minus a negative 36x, that's a positive 20x over x squared minus 4 squared. So thankfully, this actually cleaned up to be a nice looking function at the end. I know you might say that doesn't look very nice, but it could be worse. Okay? This one only has one thing in the numerator, one thing in the denominator. So if I want to find critical numbers, the definition of critical numbers is that you figure out what makes that function equal to 0 or what makes it undefined. The way you figure out what makes it equal to 0 is you set the numerator equal to 0. The way you figure out what makes it undefined is you set the denominator equal to 0. Okay, so let's see. To figure out what makes it equal to 0, I just get 20x equal to 0 divided by 20, and that one's pretty easy. X is 0. Okay, so there we go. We got 1. What makes it undefined? Well, we take a square root of both sides. We get x squared minus 4 equals 0. We're going to add the 4 over. So x is equal to plus or minus 2. Now, x equal to plus or minus 2 and x equal to 0 are my critical numbers. But do you notice anything interesting? Look at all the work we've done. And in particular, pay attention to the x equal to plus or minus 2. Say that again? Yeah, we have two asymptotes at plus or minus 2, right? So I can't use those as critical numbers. Okay? I can still test them, but if they change direction, they're still not critical numbers. Okay? Because that means that they would be on the vertical asymptotes. All right? So just something for you to think about, because right now when we do our sign graph, we're going to figure some stuff out. So let's do the sign graph right here. F prime of x. And I'm going to put a 0 here, a negative 2 here, a positive 2 here. And notice what I'm going to do. Right at the negative 2 and the positive 2, I'm actually going to draw out my asymptotes. Okay? That way I know, like, look, those can't be critical numbers because there's asymptotes there. But I can still test to see what happens. So that's just something that I tend to do. Not everybody has to. I mean, you don't have to do it, but I just tend to do that. So let's check out what happens before negative 2, between negative 2 and 0, between 0 and 2, and after 2. Okay? So we're going to plug it into our derivative function. Okay, this is our derivative function right here. Okay, we're going to plug it into there. So let's plug in a negative 3. I'm going to give you a second. If you were to plug in a negative 3 into that function, would the answer be positive or negative? I don't care what the answer is, but would it be a positive or a negative value? If anybody thinks you know, just raise your hand. I'll take your answer. Positive or negative value for a negative 3 into the derivative? Negative. Notice will the denominator ever be negative? No, because it's something squared minus 4, and then you square that. So denominator, it doesn't even matter. It doesn't matter what I plug in. It's always positive. So the only thing that matters is the top, right? And if I plug in a negative 3, I get 20 times negative 3. That'd be a negative 60, so my answer is negative, right? So it would be negative. Now, what about a negative 1? Again, the bottom doesn't matter. So positive or negative? Negative. So would negative 2 be a critical point if there was no asymptote there? No, it doesn't change direction, right? So we know that. Okay. Now let's plug in a 1. What should I get? A positive. And what if I plug in a 3? Also positive, because it doesn't matter what the bottom is, because it's always going to be squared. What matters is the top portion, right? What happens up there?
I was just wondering if you have extra boxes of tissues.
Yeah, 1 second. All right, so that we found our critical numbers. If you want to do a little skeleton graph of what this looks like, it would look like this. Down, down, up, and up. Okay. Now, I don't know if it's crossing the x-axis there or not. I have no idea, but I mean, actually, I do have a pretty good idea what it's doing, but right now, this is what I see. Okay, it's going down, then down and then up. There's only one critical number, right? So let me just write this right here. So my critical point is at 0 comma something. All right. Whoa, that's some crazy. We're having a rave, I think. This is kind of weird. Give me a second. Still working, but it's doing something very weird. Hold on, give me a second. All right, so we're going to go all the way back up to look at our original function. So there's our original function. If I plug in a 0, it's 9/2. That means my y-intercept is going to be my actual critical point. Okay, so I'm going to put that all the way down here in this answer. So for my critical point, it's going to be at 0 comma 9/2. Let me see, 0 comma 9/2. I'm going to put a little box around that because that's an answer that's important for me. Okay. So after that, I have one more thing to do before I get to draw. That's the second derivative. So f prime of x is 20x over x squared minus 4 squared. Okay. Now I need to take a second derivative to find my points of inflection. All right, so let's take our second derivative here. So f double prime of x. So the derivative of 20x is 20 times the bottom, x squared minus 4 squared, minus the top, which is 20x, times the derivative of the bottom. Notice that's going to be a chain rule because it's a quadratic function within a quadratic function. That's an x squared minus 4 stuck inside of something squared. So we got to work with that power first on the outside. So bring the power down. That'd be a 2 times x squared minus 4 to the first power times the derivative of x squared minus 4. That's 2x. And there's a derivative of the denominator. So 2 times x squared minus 4 times 2x. All of that is going to be divided by x squared minus 4 to the fourth, because it's a squared squared. Now, I'm going to simplify, but not completely, okay? I'm going to try to do this in a way that's going to allow me to break some stuff down. So I'm going to leave the first term exactly the way it is for now. But the second term, I am going to multiply a couple things. I have a 2 times a 2 times a 20, so that's 80 x squared times x squared minus 4. Okay, because 2x times 2 times 20x, that's 80x squared. And then x squared minus 4. On the bottom, x squared minus 4 to the fourth. Do you guys see what I'm trying to do? Like, check this out. Okay, I can take out an x squared minus 4 from all those things. Okay, and when I do that, I'll be able to cancel some stuff out and simplify this thing just a little bit more. So I can also take out a 20 from everything. So let me take that out. So a 20 x squared minus 4. I'm going to change the color of the result. That way it makes it's a little bit different. So the result of what's left over on top is going to be x squared minus 4 for the first term, because the 20 and one of the x squared minus 4 is gone, minus 4 x squared, okay, and then divided by x squared minus 4 to the fourth. So notice I took out a 20 and an x squared minus 4. So the only thing that was left over was an x squared minus 4 for the first terms. And then on the back end, 80 divided by 20 is 4. So 4 and x squared stays there. That x squared minus 4 to the first was taken out. So that's gone. I can cancel this x squared minus 4 with one of these. So that's going to be a third power now. And I can combine what's inside of that blue section. So this will be 20. X squared minus 4x, that's negative 3x squared. And then minus 4 over x squared minus 4 to the third. Now if I simplify that by putting that 20 back in, this is going to look like this. Negative 60x squared minus 80 over x squared minus 4 to the third. Now I'm ready to solve for zeros. Okay? You see why I say this might take 2-3 days? Right? I'm not trying to rush through this. Okay? So this is another reason why it takes long. I mean, this might take you a good 5 minutes. If you know what you're doing, you can go through and get this done in 5 minutes. But usually the first time you see this, you're not really sure of what you're doing yet. Okay? So yeah, don't be shocked if this takes you 10-15 minutes per problem. Start the homework immediately. Okay? This is one of the reasons why I only give you one of these on a test. Okay? And I take 20 minutes into consideration for that one question. Okay? So, all right. So, let's figure out what makes this equal to 0 and what makes it undefined. So negative 60x squared minus 80 would make it 0. And x squared minus 4 cubed equals 0 would make it undefined. So let's do this problem here. Let me make sure we have So go ahead and solve the top, or not the top, but the first one and the second one. I'll give you guys a little bit of time to do that. So I'll kind of start doing it on my own here. Negative 60x squared equals 80. X squared equals, what would that be, 4 negative 4/3. Hey, because you can't take a square root of a negative number, right? No. So there we go. No solution for that one. For the other one, we get, if we take a cubed root of both sides, we get x squared minus 4 equals 0, or x squared equals 4, or x equals plus or minus 2. But what did we learn about that? Those are asymptotes, right? So the points of inflection, there's none of them. No actual points of inflection, but I can still do the sine graph to see if it's concave up and down. I just can't name anything a point of inflection. So let's do that. Okay. All right, so here we go. F double prime of x. There's a 0 here, a 2 there, a negative 2 there. I'm going to draw my asymptotes here. Okay, so we're looking at this section over here, okay, when we're plugging stuff in. So let's try a -3. If you plug in a -3, and if you guys don't mind, if it's okay, I'll just tell you what happens. That way we don't waste too much time. If you plug in a -3 into that equation, you end up with a negative answer. Okay? Now, if you plug in a -1, you end up with a positive answer. And I don't know what happened to that too. Give me a second. Why is it going away? I'll redraw it. It's getting closer to Halloween. Maybe it's haunted. All right, now if you plug in a 1, it's going to be positive. And if I plug in a 3, it's going to be negative. So that gives me concave down, up, up, and down. So if there wasn't an asymptote there, then you would say -2 and 2 would be points of inflection, because it does change concavity at -2, and it does change concavity at +2. But since those points would have to lie on a vertical asymptote, then you can't actually call them points of inflection, right? So that's why we say there's none. So I'm going to kind of put a little box around here. So now we're done with everything we need to do besides drawing a picture. Okay? So before we advance, are there any questions with any of these steps? Again, we found x-intercepts, y-intercepts, x-intercepts, y-intercepts. We found horizontal and vertical asymptotes. We found critical numbers. We found points of inflection, or I guess didn't find any points of inflection. But we did find out what happens there, right? So here we go. Let's draw it. I'm just going to put it down here. He did. That's why he created calculus. Imagine doing this with algebra. Oh my goodness. You can. I know. But I want to make sure I have enough room to do stuff without trying to squeeze like little lines here and there. All right, so I'm going to depend on you guys to give me some information, okay? That way I don't have to keep scrolling back up and down, etc. So what was my x-intercept? Plus or minus 3. So -3, there's one right there. +3, there's one right there. What was my y-intercept? All right, 9/2, that's 4.5. So right there. Okay. So I got my intercepts. Next were my asymptotes. Where were my asymptotes? The vertical ones. Plus or minus 2. Okay, thank you. So here's one of them. And here's the other one. Okay, what was my horizontal asymptote? 2. Now just real quick, can you see how like I'm going to have to pass through these points, right? That means that, and I'm going to erase this stuff right now, but part of my graph is going to live here. The other part's going to live here, and the last one's going to live right here. Because they can't cross through those vertical lines, right? And the horizontal ones, usually you can't cross. There are some cases where you can, but we'll deal with that later. But that's where it's going to basically reside, okay? Now, we know that this graph is going to have to be, let me see, we already did the asymptotes, now the critical numbers, right? So we know that this graph is going to have to be decreasing at this point right here, right? It's going down throughout that, or actually, hold on, let me put it in a different way. Before -2, it was decreasing, right? So look what I'm going to do. I'm just going to kind of do this. Give me a second. So before -2, it's going down. From -2 to 0, it's going down, right? Then from 0 to 2, it's going up. And then from, I didn't draw this one right. And then from 2 on, it's going up. So, and then remember, it's concave down, up, and down. All right? So I'm just going to draw you guys the answer for this really quick. And then let me show, we'll talk about it on Tuesday. It's going to look like this. That's our graph.